We have like a 2 hour lunch break. Can we, like,
Oh, I don't get it because I was selected for the relay race team. What are you doing?
Oh, really?
Or like which lane?
You can. There's like the. I mean, what have you done? You know. So I think like it was just a bunch of names.
It's actually super great.
Okay.
What's your name?
Hey, Brandon.
I'm only.
Brandon, how you doing?
Better.
I'm good.
Not the pox, thankfully.
Oh, okay.
I like the reactor.
Yeah,
Alright.
I think, yeah, sounds good. And then,
Everyone does.
yeah, but I guess no.
I don't know how I feel about it. Like, I know I can't balance the day.
Yeah, that's gonna. Wait, do you know what leg I am now?
What?
Oh, because it's a person, oh, it's a 2-person race.
Yeah, yeah.
Oh, so,
So you're on the three-legged race.
so I'm first.
Anybody know who this is?
You know what a three-legged race is?
You know?
Your inside feet are tied together. And then you have to run together.
The greatest sausage fingers of all time.
But it's good, like, look.
I know the song. I just don't know.
You know the song? You know the song.
That's the three-legged.
What a great song.
Great.
Ryan, who is it? Mark Anthony, yes, sir. So good. Man. Good morning. Just there, just under the wire. Take a moment to discuss the date, please. I'd like to hear some insight about the date.
Brian, you have any insight for the date?
Oh, yeah, it's correct. It's.
Okay, yes, okay,
That's right.
okay. And how did you get the 10?
36 plus 54 is 100.
Seems pretty straightforward. Are we good with that? Any other insight? No? You didn't think about it as a geometry student? But could you? We see it's a triangle and the legs.
So the piece of legs is close last time because it's a plus, right? A squared plus B squared. If I have the legs. Okay. Enough of that old stuff. Let's do some other old stuff. But new. Let's see what you can be for. Warming of the up.
Your neighbor's gotten a good start for that simple one. They were doing the deed as well. Yeah, you're doing both one and two. No, there's no problem like that. Like, have you seen a problem like that second one? Yeah. Where do you see? They were in the all the planning problems.
Over with your paper if you haven't already. On something number one, just a moment. Dylan, can you help us out with number one, please? Equals one, so, okay. We're good with these? Yeah. Absolute value equation, so make sure to check. Let's make sure to do they both good. In your work, if you do something like this, if you leave the absolute value on for both of them, I will be marking that down. So, you know, the whole point of setting it equal to positive and negative 5 is to remove those absolute values. Make sure that you don't leave them for too long. In fact, if we have something like this, we configure for that. It's a problem because there is no solution. Do you see that? Absolute value equal to negative 5. Yes, it's also working divided that -2 is equal to 5.
And you got the right answer?
Yeah.
You got negative 7 thirds?
I said negative 3 x -2. Oh, so you multiply the left side by negative 1, so the right side by negative 1. Yeah, that's fine. As long as one of the sides is multiplied by negative. Interesting. Number 2, would you like to tell us how to do that? Then 300. So Okay. So. Okay. I'm just gonna put the negative on the outside. So like negative. Negative, that's -6. You said they were making to make 4 of them? Yeah, well, and the other one just the original. Without the absolute values. What do you think? Does that make sense? Mix and match. All possible combinations and you know. Like cross out both of them. Yeah, you don't do that. Really? They're the same as which one? Well, the third one, same, the second one. So we have 1, 2, 3, 4. Cross out 2. 2 and 4 is the same. So we have some redundancies. Do we agree that 3 and 4 are the same thing? Nice. So I'm gonna cross out a more complicated one. And 1 and 2 are the same thing? Yes. So what did you get in there? Are we good with that? Do we check really quickly? Make sure we're right. So if this is that's -4 gives us, what is that? -12 plus 2, so -10 on the left. 10 on the right. And the 1 gives us. Got all solutions. So finish up the chapter today, or the unit. So next time we're gonna have our
Review and the time after that. The test. Yay. Something to get excited about. Where are we? More on slope. Will you please discuss what you know about slopes, parallel lines, and not only parallel, but also perpendicular lines? Please discuss. Oh. Ava? Dylan, I have a brand new partner.
Yeah.
Okay. So I'd like to know what you discussed. Me and Lauren.
Can you say it one more time? Yeah, perfect. We can stop right there. Parallel lines have
The same slope. Are we good with that? Okay, and do you want to continue? Yeah, or do you want me to choose something up there? Does that sound right? Sound familiar? That's exactly what I was looking for. Thank you so much. Yeah, so parallel lines, the best way to spell parallel, of course, is like this, isn't it? Don't you agree from geometry? Parallel lines.
have the same slope. And perpendicular lines. How do you spell perpendicular?
Upside down. T, yeah. Instead of negative reciprocals, which makes sense, I'm gonna say opposite reciprocals. Remember, negative means opposite in mathematics. I'm just getting more direct to the concept. So they have slopes that are opposite reciprocal. Reciprocal.
In other words, if the slope of one line
is, well,
Slope of a perpendicular line would be one of them. And then. There's one exception for us. Exception when two lines perpendicular but their slopes are not opposite reciprocals. Or, yeah, horizontal. Those aren't reciprocals of one another, but they're definitely perpendicular. I guess I'm trying to work for examples 1
and 2.
Ready. Example 1. Sasha, are you able to finish this one? Yep, stop, please. And where do they keep from? What do we think? Do you have to do anything with that equation or are we done? That's what. Are we good with this? Now, where's a good place to stop? Like, do you have to work all the way to
Y equals 2x plus 7. I like to express this in point slope and slope intercept. Yeah. If it didn't ask that, of course, then please stop with the first one. But since it asks for both, yes, give you both. Nicely done, Sasha. Thank you. Any questions? We're given the equation that first line in slope intercept form can't get much
more direct than that?
Example 2. Dun, dun, dun. Will be from Ryan. Okay. Mhm. Okay. The perpendicular line is going to be positive 4 like this. Okay.
True. Slopes as rate of change. You'll see slopes embedded in word problems, and
that the slope is there is if you see a rate of change. In other words, if rain is falling and they tell you that there's been like 20 inches of rain in 4 hours. Does it make sense that might be a slope of inches per hour? That's because it's a change of some quantity over change of another quantity. Or if you're working a job, you might be making money, and that money comes in at a rate of some like X dollars per hour. So when you see that kind of rate, it translates to a slope. Here we have line graphs for the living arrangements of young adults are shown. Find the slope of the line segment for the percentage of young adults age 25 to 34 owning a home. Describe what the slope represents. Okay, so the year 2000, there's some data, 2005, 2010, etc.
There's like the other.
What do you mean?
Like, I think beginning when you were 45 and like 12.
True. Well, it's I imagine that a lot of people just don't own homes. So this is saying that in the year 2000, young adults, there 45% of the young adults own homes. Oh, and they own living with parents. Yeah, so what are the other options? I see what you're saying. They own a home, live with parents, or without other arrangements. That's a really interesting question. It has to add up to 100, doesn't it? Everyone has to live somewhere, or else they're dead. But other options? Roommates? Roommate? Apartment? Right? If you live in an apartment, you don't own your home. Or renting a home? Homeless? Living on the street? I think that's interesting. But yeah, interesting question. So go ahead and discuss what's going on with these two lines here.
For this one, owning home. Of course, the slope is
Gonna be mega business. So what 38.4 minus 45.4 over, can I just write 17? Did anyone get that value?
thank you, Russ. Don't advocate. Well, it's not it's like the beads that you move over to
One of my students was a master at abacus, and he could do calculations like this without problems in her head because of that. Pretty interesting.
Negative point 411.
Yeah, 0.411.
4.
412. Oh, thank you. Okay, so what does this mean? Yeah, it's not being specific. So when in doubt, 3 decimal places is a really good rule of thumb. So what this means is that the percentage
Young homeowner.
Home ownership. Let's say decreasing at a rate of negative.
0.412? That, yeah, that's the opposite of what I want to say, isn't it? Decreasing at a rate of 0.412% per year. So I'm gonna want to see some sort of this per that. If you just tell me decreasing at a rate of 0.412, it's not enough information. The other one. For the other one, the slope is equal to what, 22.0 minus 11.9 over 17. I think I could do this one. What is that? 10.01? 10.1, excuse me. Is that right? I think that's right. Divided by 17. 0.629. Thank you. And again, we're at percent per year. By the way,
He's raised,
Only time I accept that slash. Anything. Separate the top and the bottom. Okay, so. Put into words, percent of young living with their parents is. Increasing. You can say increasing at a rate of 0.629% per year. Young people living with parents, percentage of
the percentage of young adults living with parents is increasing at a rate of 0.629% per year. I know, it's exciting. I think there's some commentary here, isn't there? Some social commentary, don't you think? We have two extremes of people who have graduated college or of age to have graduated college and possibly getting married. And as time goes on, it is getting harder and harder to own a home. And of course, it's getting harder and harder to leave the place from which they came. Hopefully you all live at home. But hopefully that won't be the case in 20 years from now. Hopefully, you'll fly. I think most of you will. I believe in you. If you study algebra 2 really hard, there's a chance. Average rate of change of a function. Okay, so you can see here that this is the graph of a kid. Do you have one of these graphs in your home? Where you stand tall against the wall and they make a line about how tall you are? Who has one of those in their home? It's kind of fun to look at that. There, you're gonna have to get some taller rooms pretty soon. It's gonna be interesting. Anyway, yeah, so that's just kind of a graph over time about your growth. Here's a particular person. Notice, is the graph steady? No, everyone has growth spurts and times and it slows down. When does your growing actually happen? Do you know? Like, are you growing right now, possibly? It's when you sleep. Yeah, you grow when you sleep. Mostly. There might be some growing when you're older, but when you're asleep. Isn't that interesting? Wake up a little bit taller. Are you girls still growing? Or did you reach that peak? It's not fair. Not fair. Like I gotta write the government or something. So if we're looking for average rate of change, the rate of change is constantly changing. If you're looking for average rate of change, all you care about is like, where is he here? Oh, I see. There's already a line here. You can see that the line that you get here is illustrating. This is the average rate of change for the ages of 13 to 18. So we get the slope of that line, we give us the average rate of change, even though there was like a huge increase from 13 to 15, and then that leveled off. That's it. For young men. I don't know what they want to say here. Okay, so let's say that we have this function. And I'm going to try to be very intentional about this. So I'll put this A over here and this B over here. You can see on this interval, this function is both increasing and decreasing, isn't it? At this point, we have a relative minimum. At this point, was
Absolute fact. So it's the relative fact. If our relative does. That's the relative fact. Extreme up, like relative maximum. Okay, in any case.
average rate of change of this function. All we care about is where it starts and where it ends. So even though there were periods of decrease, periods of increase, if we're looking for the average rate of change, all we care about is beginning and end and find the slope here. So on average, this function is a decreasing function. We could get that just by getting the slope of that line. So find the average rate of change of f of x equals x squared from these points. Do we know what f of x equals x squared looks like? The shape is called a parabola. It is a parabola. And we'll be graphing those in detail, but for right now, let's just go ahead and make a quick t-chart in our head. I see when I plug in a 0, I get a 0. When I plug in a 1, I get a 1. That also happens when I plug in a -1, doesn't it? And when I plug in a 2 and -2, for both of those, I get 4. That gives us a nice U shape. Is this function increasing or decreasing? Yes, the answer is yes, isn't it? Depends where you're looking. So there are 3 questions. The average rate of change from 0 to 1, then from 1 to 2, and from -2 to 0. Let's see if we could already do that. Check in with your neighbor about that first one, example 4A. Make sure it's going okay. You getting them? I'm just talking about the big picture here. I hope it makes sense that summary of this problem, and I'm gonna get this ruler here. From 0 to 1, does this make sense if this is the slope of the line we're looking at right there? And then from 1 to 2, you see what I'm about to do. Let's go through these points. And of course, we notice that compared to the last one, this slope is steeper. And the last one, from -2 to 0. Hopefully we've already pictured what I'm going to do here. Yeah. You notice that the slope is negative, which we already knew. If we had a graph of this, we already knew it's going to be negative before doing the calculation. So you make sure that your calculations result in a negative number. Okay, so from 0 to 1, James can help us out with that one. Oh, so you're using the actual function. Nice, okay. Okay, so it sounds like you did maybe this kind of thing. No?
What, you do it like balancing out like 0 on the one end, then like 0 to the 0.
Okay,
And then at 1 equals 1 squared equals 1, and that's what it is.
nice. So you did 1 minus 0 over 1 minus 0, something like that, kinda. Are we good with that? Yeah, without the graph, and thank you for bringing the actual notation here. We could just do f of 1 minus f of 0 over 1 minus 0, right? Oh, 1 minus 0. We have our y2 minus y1 over x2 minus x1. So if we didn't have a graph, we could easily do it just by calculating. Nice, thank you. B. Mia, you? Are we good? And you got the 4 and the 1 from? Okay, so we're just using these points that we had here, is that right? Something like that. Okay, perfect, thank you. And finally, for C, Lily. Are we good? Nice, thank you. Yeah, so there are lots of different ways to think about this, graphically or algebraically. I guess I should say here, if this x value is a in our graph, then the y value would be f of a. And if at the end, if the x value is b, then the y value would be f of b. And I'll go ahead and mark the coordinates a comma f of a, b comma f of b. So there we can get that the slope is equal to f of b minus f of a all over b minus a. This is the slope. Or not slope, let's say average rate of change of a function Oh, things erased. So. Average rate. Of a function. On the interval. What? On the interval. So it's an x value. So in this case, the interval is from A to B. Pick your bypass the graph. Any questions? Oh, man. One last problem. I think this is it, isn't it? Yeah. One last one. I'm calling one other person for this. It should include units. Include units. I think you help solve this one, please. You're doing this is kind of your game plan, isn't it? Like one set up yourself 0.2 minus 5. Okay. We're good with this? Oh, instant negative. Okay. Can we leave the chart like this? Practicing quite well. You change that to decibel, what do you want? This is my 3/4. 0.75. We'll put this together nice. And what are the units? Units. So it's something per hour. There we go. Okay, is that big? Per hour. You're on the right track. We use a whole minute from that y-axis. So this is awkward, I know. So milligrams per 100 millimeters. Where is that? Milliliters, excuse me.
-3/400
Milligrams per 100 milliliters per hour. So it's a rate in a rate, which is a little awkward, but just trust the numbers there. Thank you, Ivy. Thank you, Nia. Any questions about these? I'm not gonna lie, I'm so sorry that this is a super dry lesson. Thanks for getting through it. Oh, wait. It happens sometimes. Sometimes it's exciting, edge of your seat action. Sometimes it's just kind of going down a slope. There's some time to stretch if you want, or work on your assignments at some point. So yeah, plenty of time today.